So what we're talking about today is still in chapter 4, section 4. So it's just part 2 of 4.4. So scatter plots will be involved, but like I said, we're going to be talking about lines of fit for scatter plots. When data show a positive or negative correlation, you can model the trend in the data using a line of fit. A line of fit is a line drawn on a scatter plot that is close to most of the data points. So you can only use a line of fit if there is some correlation between your sets of data. So if it's a positive correlation or a negative correlation, we can use a line of fit. Can we use a line of fit for no correlation? No, because our data is not related in any way. All our points are spread apart. We don't know where the line would go for those sets of data. So you can only use a line of fit if you have a positive or negative correlation. Does that make sense? Any questions on what a line of fit is? A line of fit just goes through our data, and it's a line that best represents our model in a linear way. It's close to most of the data points. Can I move on? All right. So, using a line of fit to model data, these are the steps we're going to follow to create our line of fit. So step 1, make a scatter plot of the data. You'll be given a table of some sort, or like a table of values, or a set of ordered pairs, something like that. And it'll want you to make a scatter plot of that data. That's the first thing we're going to have to do for our line of fit. Step 2, decide whether the data can be modeled by a line. How do I know if it can be modeled by a line? Yes?
If it has a correlation.
Very good. If it has a positive or negative correlation, then I know it can be modeled by a line. If it has no correlation, it cannot be modeled by a line. Okay? Step 3, draw a line that appears to fit the data closely. There should be approximately as many points above the line as below it. And we'll see that here in a little bit on our example. So do you think all of our answers are going to be the exact same? No. We're freehanding lines on paper, so it's going to be difficult for everyone to get the exact same answer. Your answers should be relatively close to each other, though. It should have relatively close to the same y-intercept and relatively close to having the same slope, right? But it's not going to be the exact same, which is okay. Step 4, write an equation using 2 points on the line. How can I write an equation using 2 points on the line? What form would I use?
Slope formula.
I will have to use a slope formula to find the slope of the line using those 2 points. And then what form do I plug into? Probably.
You would intercept.
If you know your y-intercept, you could do that if one of your points is the y-intercept. But if I use 2 points that are not the y-intercept,
You would use points.
I would use point slope form. Y minus y1 equals m times x minus x1. The points do not have to represent actual data pairs. So like I said in step 1, you're going to be using the table of values or whatever they give you to create the scatter plot. What this is saying is the points that you pick that are on the line do not have to be points from your set of data. They just have to be on our line. They must lie on the line of fit. So I'd recommend maybe having these steps down somewhere, maybe in our notes. These steps are in your book. So if you don't get them down now, you may want to go get them down later in the book. Are there any questions about any of our steps for using a line of fit to model data? All right, can I move on? Moving on. Here's an example. The table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and y-intercept of the line of fit. So here's my table. It's the weekly sales of a DVD and the number of weeks since its release. So what do you think is going to happen without even graphing this as the weeks get farther and farther away from the release? Do you think there's going to be more sales or less sales? Less sales. So what kind of correlation do you think this might have? It might have negative, but we're going to have to graph it to see if it does have any correlation. Okay? So, you guys all know that our tables of values create ordered pairs, right? So what's my first ordered pair here? 1,19, right? So these are all just ordered pairs that I'm going to be graphing to create my scatter plot. Because on the previous slide, what did step 1 tell me to do? Make a scatter plot of the data. Okay? Does that make sense? So it gives me the data. I need to make a scatter plot of that data. So, what's going to go on my x-axis? What's going to go on my y-axis? Anyone? On my graph, what's going to go on the x-axis? What's going to go on the y-axis?
Week goes on X and sales goes on Y.
Very good. It's telling me my weeks are the x values, so that's going on my x-axis. And the sales in millions is going to go on my y-axis. So here's my graph. Put week down here. And then sales in millions. It's going to go on my y-axis. I need to leave a little more room. Because my y values are getting bigger than what my graph is. So I'm going to make my y-axis go up by 2. Is everyone okay with that? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now I can put sales in millions. Everyone okay with my axes and my numbers on my axes? Now I'm going to start plotting my ordered pairs. So 1, 19 is going to be my first ordered pair. So I'm going to go right 1 and up 19, which is halfway between 18 and 20. Everyone okay with what I'm doing? It's my next ordered pair. 2, 15. So go right 2, up 15. That's my next ordered pair. 3, 13. Right 3, up 13. Everyone's still okay? That's my next ordered pair. 4, 11. Right 4, up 11. Next one. 5, 10. Right 5, up 10. Next one, 6, 6,8. Next one. 7, 7. Next one. Oops. Last one. 8,5. Everyone okay with how I've plotted my points? We good? Okay. That was step 1. Make a scatter plot of the data. Step 2, what is step 2? How do I know if it can be modeled by a line or not? If it has positive or negative correlation, right? If it has no correlation, I can't use a line. So would you say that this has positive or negative correlation? It'd be negative correlation, right? As my x values are increasing, my y values are decreasing, right? So I would say this has negative correlation. So can this be modeled by a line? Yes, it can. So there's step 2. Decide whether the data can be modeled by a line. Yes, it can. Step 3. Draw a line that appears to fit the data closely. There should be approximately as many points above the line as below it. That way it models the data the best we can. Okay? So this is one of the hardest parts of using lines of fit. Is actually drawing the line and trying to keep it straight so you get points on the line, stuff like that. Okay? So, I'm going to draw my line as best as I can. To go right through the middle of all my data to where there's hopefully equal numbers of points on both sides of the line. Okay, it's not the straightest line in the world, but it'll do. Do I have about the same amount of points on both sides of the line? Approximately? Yeah. This side of the line I've got 1, 2, 3. This side of the line I've got 1, 2, 3. And I've got 2 dots on the line. Right? So there's approximately the same amount of points on both sides of our line. Does everyone see how we did that? Like I said, not everyone's graph is going to be the exact same. That's okay. It should be relatively close though. So, step 3, draw a line that appears to fit the data closely. There should be approximately as many points above the line as below it. I've done step 3, correct? Now, step 4, write an equation using 2 points on the line. The points do not have to represent actual data points, but they must lie on the line of fit. Do you think we can use actual data points if they are on a line? Yeah. If some of our data points are on our line, we can use them. We just don't have to pick points that are actual data points. Okay? So let's go pick 2 points to use. I see 2 points that I want to use, but we'll see if you guys pick the same ones. Any ideas of which points you want to use? What I'm thinking is these 2 data points that are actually on my line. Is everyone okay if we use those? So what points are those? 5, 10. And what else? 6, 8. Once again, we used that point and that point because they are on my line. We just have to make sure we use 2 points that are on our line. Now, you won't always necessarily get it to where you have data points on the line. That's why it made that last note. The points do not have to represent actual data pairs. Questions with what I've done so far? So now all I have to do is use these 2 points to create an equation. And we do want the equation in slope-intercept form. So we probably need to use point-slope form first. convert it to slope-intercept. Okay? So what's the first step I need to do? This goes back to 4:1 through 4:3, creating equations with 2 points. Yes?
Y1 minus Y2.
Find the slope, right?
Yeah.
Over what?
X2 minus X1.
Very good. Got to find my slope using those 2 points. So what's my y2 value? My second y value? 8. Minus, what's my first y value? 10. Over, what's my second x value? 6. Minus, what's my first x value? 5. 8 minus 10? -2. 6 minus 5? 1. So my slope is just -2. Questions how I got that? Okay. Which point do you guys want to use to plug into point slope form? Does it matter which point we use? No, which one do you want to use though? 5, 10, or 6, 8? 5, 10, let's do it. Y minus, what's my y value from the ordered pair I'm using? And 5, 10, what's the y value? 10. Equals, what's my slope? -2 times x minus, what's my x value? 5. We okay so far? Everyone understanding how we're using these steps to get our line of fit? Okay, what's my next step to get the y by itself? What do we call that? Distribute. -2 times x. -2x. -2 times -5. -2 times -5. +10. And how do I get y by itself? Add 10 to both sides. So I get y equals -2x. What's 10 plus 10? Plus 20. So here is my equation of my line of fit for my whole data set. Does everyone see how we got that? Any questions? Okay. So, let's see if we've covered everything. The table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. So we did that, right? Y equals -2x plus 20 would be our answer. Does it want anything else though?
It wants us to find the slope and y-intercept of the line of fit.
Yep. It says interpret the slope and y-intercept of the line of fit. Right? So what was my equation? There's my equation. What is my slope? -2. What's my y-intercept? 20. It wants me to interpret those according to this situation that it gives us. Okay? So, my slope is -2. Remember, my slope is my change in y over my change in x. So it is negative 2 over 1. So what do you think my slope means in this situation if my change in y is negative 2 and my change in x is 1? Well, what are my y values representing? What are my y values representing according to my table? What's next to the y? Sales in millions, right? Over my change in x values, what's my x values representing? Weeks. So what do you think negative 2 over 1 means? Change in y over change in x for this specific situation. Let's think about it. If the numerator is my change in y, so that's sales in millions, and it's a negative 2, is that increasing or decreasing? Decreasing because it's a negative, right? So the sales are decreasing by about $2 million. How often? Well, what's my change in x on the bottom? Per one, what is the units for x? Week. So to interpret the slope, I could say the sales are decreasing by approximately $2 million per week. Does that make sense? Because it's my change in y over my change in x. Decrease in my change in y. Sales are decreasing by about $2 million per 1 week. Does that make sense from my interpretation of the slope? Okay. Now let's look at the y-intercept. Y-intercept is 20. What's the x value of a y-intercept? Zero. So what do you think my y-intercept means in this situation? Well, what do our x values mean? Weeks after its release. So if the x value is 0, that's 0 weeks after its release. Are there going to be any sales 0 weeks after the release? No. So our y-intercept does not have any meaning in this situation. That's what I would put. Does that make sense? It's all about the situation we're given. In week 0, 0 weeks after the release, there's not going to be any sales. So the y-intercept does not have any meaning in this situation. That's what I would put for my interpretation of the y-intercept. Does that make sense? Questions on our example here? We okay? Can we make lines of fit on our own now? Yes. All right. Page 204, numbers 13 through 18 all. That's 6 problems. Okay? Page 204, 13 through 18 all. This will be due Thursday, January 13th on Canvas. Are there any questions about my notes before I end the recording? All right, I am going to give you graph paper because it is going to require you to graph some of these scatter plots to create your lines of fit. So I will give you the graph paper.